All right, so we're going to start with the Pythagorean identity. So the Pythagorean identity is one of the most common ones you're going to use. And if you remember when we did the unit circle, the way that we were able to get our x's and our y's is we did a little table here, x, and then this was my y, and this is my r. And if I take this triangle and I use Pythagorean theorem, I know I'm going to get x squared plus y squared equals r squared, which is conveniently the formula for a circle that is centered at 0, 0, if you remember from geometry. Now in the unit circle, my radius is 1, so I can change this to x squared plus y squared equals 1. And then we know from our unit circle, x is cosine of theta and y is sine of theta. All right, well, this, I can just play the substitution game and I can get cosine squared theta plus sine squared theta equals 1. There is a Pythagorean identity. There are 3 of them. So I'm just going to put it over here. Cosine squared theta plus sine squared theta equals 1. Okay, now let's have a little bit of fun. Let's say I just divide the whole thing by cosine squared. Why? Because I can. So I'm going to divide cosine squared theta on all my sides, on every element. Well, cosine squared theta divided by cosine squared theta is 1. Sine squared theta over cosine squared theta, well, we saw this is a ratio identity. Sine over cosine is tangent. These are both squared. So this becomes plus tangent squared theta. And 1 over cosine squared theta, we saw in the reciprocal identities, this is going to be secant squared theta because it's squared. Here is my second Pythagorean identity. 1 plus tangent squared theta equals secant squared theta. All right, let's go back to my original one. Cosine squared theta plus sine squared theta equals 1. Now, instead of dividing everything by cosine squared, let's do sine squared. So we're going to divide by sine squared. Everything by sine squared. Cosine over sine, we learned from the ratio identities that this is cotangent squared. Sine squared over sine squared, well, that's just 1. And 1 over sine squared, we learned from our reciprocals that this is cosecant squared theta, and there is my third Pythagorean identity. All right, so let me show you an example of how we can use the Pythagorean identities, and some of y'all may have already discovered it from websites when you're trying to solve problems. Now, if Euclid taught us anything in mathematics, is we're not allowed to use something until we have proven it. Now that we have seen these identities, now you're able to use them. All right, so let's take a look at a way that we can use the Pythagorean identity to solve a problem that we've already done, where we've drawn reference triangles, or at least we're supposed to draw reference triangles, and then we're supposed to use Pythagorean theorem. But Pythagorean theorem, well, the Pythagorean identities is based off the Pythagorean theorem, so we're going to be able to solve these problems. I still think it's considerably easier the other way, but let's go ahead and do this. All right, let's say we do secant of arctangent of, let's just keep this simple, 3 over 4. All right. Well, I look here and I need to know secant, and I have a Pythagorean identity that says secant squared theta equals 1 plus tangent squared theta. Well, I don't need secant squared, I just need secant, so I'm going to just get rid of the square. I'm going to take the square root. So secant theta equals plus or minus the square root of 1 plus tangent squared theta. Okay, well, arctangent of 3/4, that's my theta, so really my tangent is 3/4. So now I can just plug this in and solve. So I can do 1 plus 3 over 4 squared, and I'm going to take the square root and we're going to do plus or minus. All right, this is going to give me 1 over 9 over 16. This is going to give me 25 over 16. Don't forget your plus or minuses. This is going to give me plus or minus 5 over 4. Voila. Now I come back here, arctangent, well, it's positive in quadrant 1, so I only need the positive, so my answer is 5/4. So this is how you can use a Pythagorean identity to actually solve these compositions versus the way that I showed you. You simply just draw this as a reference triangle, and tangent is opposite over adjacent. We know my hypotenuse is 5 from Pythagorean identity, and knowing the definition of secant is hypotenuse over adjacent. That is going to give me 5 over 4. I think this way is a whole lot easier than this way. But now that I've taught Pythagorean identities, if I give you one of these problems, you can absolutely solve it this way, the way that most websites apparently solve it. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.